This presentation will review the Georgia Standards of Excellence for MBT5, which focuses on using place value understanding and properties of operations to multiply multi-digit numbers. For MBT5 states that students will multiply a whole number of up to 4 digits by a 1-digit whole number and multiply two 2-digit numbers using strategies based on place value and the properties of operations. Illustrate and explain the calculation by using equations, rectangular arrays, and/or area models. Note that the standard algorithm for multiplication is not an expectation until 5th grade. To develop fluency with basic facts, 3rd grade students use flexible thinking as they explored patterns and relationships. For example, if you know your doubles facts or you can multiply by 2, then you can also multiply by 4 by simply doubling the product. The same pattern continues as you multiply by 8. You simply need to double the 4's fact. 3rd grade students also explored properties of operations. For example, when multiplying 4 times 7, the factors can be decomposed in different ways to find partial products. The partial products can then be added together to find the total product. This understanding lays a critical foundation for success when multiplying multi-digit numbers. 3rd grade students also explored multiplying a single-digit number by a multiple of 10. For example, when solving 7 times 20, students can use facts that they know and the properties of operations to find the product. In 4th grade, this understanding is then expanded to larger numbers. To scaffold understanding, the game Multiplication Pop can be played in the classroom. This game builds on previous understanding of multiplying by multiples of 10. The game reinforces place value understanding and how multiplying by 100 creates a number that is 100 times larger.
Your turn, Maddie.
He'll mark it off. Yeah. And then it'll be your turn. Like, are y'all team or are y'all individually? Okay. All 3 of y'all are playing.
10.
You're not going to color. So how do you
1,000.
The use of concrete manipulatives and visual representations is important to continue in 4th grade as students make connections to previous learning while exploring multiplication with larger numbers. For more information about the progression of multiplication and how students gradually transition from the concrete to the abstract, please view the video by Graham Fletcher that is linked below this presentation. In multiplication show and tell, students build a multiplication expression that they then model and explain. Students create and combine equal groups to find the total product.
Show me 4 times 36. And I know that 4 times 30 equals 120. And I know that 4 times 6 equals 24. And this equals 120 plus 24 equals 4 times 36 is 144.
In addition to base 10 blocks, students can use place value discs to create equal groups. After creating 9 groups of 112, the students then regroup the hundreds, tens, and ones. How many ones do we have altogether?
18.
Can we regroup them?
We can take these off.
How many would you take off?
10.
10 what?
And
10?
10 ones. And then we would put 10 in the tens spot.
Okay. So 10 tens make 100. Now how many hundreds do you have?
10.
Okay. Can you regroup 10 hundreds?
Yes, we can make 1,000.
Okay. So the product of 112 times 9 is
1,008.
In the next couple of videos, students build area models with base 10 blocks. They then combine the partial products to find the total product.
So that's 200.
So the product is...
91.
So can you find the partial products?
Yes. I'm multiplying 16 times 50.
Okay.
So 10 times 10 is 100. And 10 times 5 is 50. Yeah, I did that right. Is 50. And then 10 times 6, 60. 5 times 6 is 30. And then we add it.
So what's the final product?
240.
Practice with concrete and representational area models allows students to make connections to the partial products algorithm. Most importantly, the focus in 4th grade is on place value understanding. Games and hands-on tasks are a great way to encourage a deeper understanding of multiplication. In the upcoming video, students use the area model and compete to create factors that will have the least product. One student chose to multiply 35 times 48, while the other multiplied 34 times 58.
He won again. His product is about 300 less than mine, so he won. I also knew from the start because 30 times 40 is 1,200, and then 30 times 50 is 1,500.
In the next game, the students used 5 cards to create a 4-digit times 1-digit equation. This time, they were looking for the greatest product. The video shows the students using the partial product algorithm. As the video shows, the students use their understanding of how the place value of the digits and the factors affect the partial products. Who has the greatest product?
I do because 59,000 is greater than 26,000, and I knew from the start that mine was greater because 8 times 7,000 is greater than 3 times 8,000.
To add rigor and relevance, instead of just giving students predetermined factors to multiply, allow students to apply their knowledge of partial products by solving problems such as this. The upcoming video shows how the student predetermined the missing factor and product by using place value reasoning.
One of the factors is 23.
Could you have written 23 on the side to get these partial products?
No, because you cannot divide 100 into 3 equal groups.
That's right. So 20 times what equals 1,200?
It equals
60. Then 20 times what equals 100? So our other factor is, okay, can you finish the partial products? 60 times 3 equals 180, and 3 times 5 equals 15. Now add up all your partial products to get the total product. By presenting a different way, the student was able to demonstrate true understanding of multi-digit multiplication. Here's another example of how any traditional math problem can be turned into an opportunity to increase rigor and assess understanding. The student knows that 32 is the product of multiplying the ones by the ones, and then uses other clues to find the missing digits. What are you going to do next?
I need to multiply the 8 by the 10s, and I'm going to put a 0 right here.
What does the 0 show?
The 10s.
Okay, so what could this be? What could that factor be? If we add 2 plus 0 to get 2, and we add 3 plus what to get 9?
3 plus 6.
Okay, so 8 times what equals 56 tens or 560?
8 times 7.
Is it just a 7 or is it, what's the value of that 7?
70.
Okay, so 8 times 70
Equal 560.
Problems like these can be differentiated based on the needs of the students. This example is more challenging. With the given clues, the student knows that the first partial product is a 2-digit number and can conclude that the factors are 9 and 3. but until solving additional components, they do not yet know the placement of the factors. To replace traditional worksheets and rote calculations, teachers can modify problems and students can create their own puzzles for classmates to solve. For additional support and reinforcement, students can explore partial products and area models with this interactive game. With this tool, students can create factors and decide how they want to decompose each factor. They can view the models with grids or base 10 blocks, as well as see the partial products within each area. For more information about 4 MBT5, please visit GeorgiaStandards.Org for additional tasks and resources.